Imagine a conversation with an AI that doesn't just understand you, it sounds like you. Not just in tone, but in the rhythm, the breath, the subtle quirks of your voice. That's no longer science fiction. Today, we're diving deep into Chroma 1, the first open-source, real-time, end-to-end spoken dialogue model that delivers high-fidelity voice cloning with sub-second latency. This isn't just another voice assistant. It's a full-fledged, personalized, streaming speech AI that thinks, speaks, and sounds like you, all in real time. Let's break down how it works. The problem: most voice assistants today use a cascaded pipeline. Your voice goes through automatic speech recognition, which converts speech to text. That text is processed by a large language model, and finally, the response is turned back into speech via text-to-speech. This approach has serious flaws. First, it's slow. Each step adds latency. Second, it loses paralinguistic information, things like speaking rate, timbre, emotion, and prosody. These aren't just nice-to-haves, they're what make a conversation feel natural. And third, voice cloning is usually a separate, post-hoc process. You give a sample, the system builds a voice profile, but then it can't maintain that identity across multi-turn conversations. Or if it can, it sacrifices speed. So the dream has always been a single, unified system that understands speech, reasons like a human, and speaks back in your voice, all in real time. That's exactly what Chroma 1 delivers. Chroma 1 is built on a tight coupling between speech understanding and speech generation. It doesn't transcribe speech to text and back. Instead, it operates directly on discrete speech representations, using a neural audio codec to turn raw audio into a sequence of discrete tokens. Think of it like this. Instead of processing language as words, it processes speech as acoustic symbols, like a secret codebook of sound. The architecture is split into 4 core components. The Chroma Reasoner, a multimodal understanding engine that processes both text and audio inputs. The Chroma Backbone, a 1 billion parameter LLaMA-based model that generates coarse acoustic codes. The Chroma Decoder, a lightweight module that refines those codes with fine-grained detail. And the Chroma Codec Decoder, a causal convolutional network that reconstructs the final audio waveform. But here's the magic: they work together in real time. To enable true streaming, Chroma uses a 1-2 interleaved text-audio token schedule. For every 1 text token the model generates, it produces 2 audio code tokens, not all at once, but incrementally in sync with the text output. This means, as you speak, the system starts generating speech before it finishes processing your full input. It's not waiting for a full sentence. It's generating audio in parallel with the reasoning process. The result? A time-to-first token of just 146.87 milliseconds, under half a second. That's fast enough to feel like a real conversation. And because it's end-to-end, there's no error propagation. No mistranscriptions. No loss of emotional nuance. The model understands the whole signal, linguistic and acoustic, as a unified stream. Now let's talk about voice cloning, the crown jewel of this system. Chroma doesn't need hours of training data. It can clone a voice from just 3 seconds of reference audio. How? By encoding that reference audio and its transcript into a prompt embedding, and feeding it directly into the model as conditioning context. The model learns to map semantic content to acoustic style, preserving timbre, pitch variation, speaking rate, even breathiness. And the results? 10.96% relative improvement in speaker similarity over the human baseline. Yes, the AI-generated voice is more similar to the original speaker than a human voice would be in a controlled evaluation. But here's where it gets fascinating. When we compared Chroma to LLaMA, a top-tier commercial voice cloning system, the results were surprising. Naturalness, LLaMA won, 57.2% preference versus Chroma's 24.4%. Speaker similarity, Chroma was nearly tied, 40.6% versus LLaMA's 42.4%. But then came the real revelation. We asked people to compare LLaMA's output directly to actual human recordings. And the result? 92% preferred the synthetic voice over the real one. This isn't a flaw, it's a revelation. Listeners don't care about naturalness as much as they care about consistency. LLaMA optimized for clarity, smoothness, and polish. But in doing so, it may have smoothed out the subtle imperfections that make a voice authentic. Chroma, by contrast, preserves the real, messy human qualities, the slight stutters, the dynamic pitch shifts, the natural rhythm. So while it may sound less natural in a technical sense, it sounds more human in a psychological one. Despite being only 4 billion parameters, Chroma delivers competitive performance across reasoning, understanding, and oral conversation tasks. On the URObench benchmark, a rigorous test of end-to-end spoken dialogue, Chroma ranked 2nd in reasoning, 2nd in summarization, and 1st in oral conversation on both MLC and Common Voice. It outperforms larger models like GLM4 Voice, 9B, and LLaMA 8B, all while using fewer than half the parameters. And the real-time factor is just 0.43, meaning the system generates speech 2.3 times faster than real-time playback. That's not just fast. It's efficient. Chroma wasn't trained on real human conversations. That data simply doesn't exist at scale with high-quality dialogue and voice fidelity. Instead, the team built a synthetic data generation pipeline. A reasoning LLM generates a response to a user prompt. A TTS system synthesizes that text into speech, using the same voice as the reference audio. This creates a massive, high-fidelity speech-to-speech dataset, perfectly aligned for training a model that both understands and speaks in a specific voice. Training itself used a two-stage strategy. Stage 1, jointly train the backbone and decoder with balanced loss weights, so the model learns coarse acoustic alignment early. Stage 2, freeze the backbone and fine-tune the decoder, focusing on refining fine-grained details like prosody and articulation. This layered training approach ensures both semantic coherence and acoustic fidelity. Chroma 1 isn't just a technical achievement. It's a paradigm shift. It proves that you can have real-time responsiveness, high-fidelity voice cloning, strong reasoning, and dialogue capabilities, all in a single, open-source, end-to-end model. And it does it with just 4B parameters, making it accessible for research, development, and deployment. This opens the door to personalized AI assistants that don't just answer questions, they speak like you. Imagine a voice assistant that sounds like your grandmother, your friend, or even your future self. Or a voice restoration tool for people with speech impairments, preserving their identity through AI. Of course, with great power comes great responsibility. High-fidelity voice cloning raises serious risks: impersonation, fraud, deepfakes. That's why the team emphasizes consent, watermarking, and detection. They're not just building a tool, they're building a framework for responsible AI. And they've released all code, models, and training data on GitHub and Hugging Face, so the community can build on it, audit it, and improve it. Chroma 1 is more than a model. It's a new kind of AI conversation. It's not just about understanding. It's about being understood. About speaking in your voice, thinking in your way, and responding with your presence. It's the first step toward a world where AI doesn't just mimic human speech, it embodies it. And it's open. It's vast. It's real. So if you're interested in the future of voice AI, this is the model to watch. Chroma 1, the first real-time, end-to-end spoken dialogue system with personalized voice cloning. And it's already live.